Hi, my name is George Blake, Whiskey 6 Bravo Delta Delta. I live in the heart of the United States in Olathe, Kansas. And I'm doing this video to show you how to build a 1000-watt antenna tuner, also known as the ATU-1000, also known as the N7DDC 1000-watt antenna tuner. These tuners were originally designed by N7DDC, and it was later upgraded, and this version of the board set is designed by EU2AV. Unfortunately, EU2AV lives in Ukraine, in Belarus, and has shut down his operation due to the war. I'm primarily doing this video because I've seen a lot of people showing off their built unit, not really describing how it was built. They show it in a nice box, its features, its operation, but a lot of people have complained about how you build this thing. And with the instructions you get, this is it, on how to build this, not very clear. I have gone about and collected a lot of other information, such as the schematic and various other documents, and found out how to finally build this device. Unfortunately, this version that I received on Amazon, the processor does not work. It's a PIC 16F 1938i/SP. It programs. I put it into my my Picket 3 programmer, checked to see there was a program. There was. Reprogrammed it, verified it was in there. It is, but there's no outputs. The LCD output doesn't work. The relay output doesn't work. So, and this is the last kit this vendor sold. So I am thinking that probably with the latest shortage in PIC controllers, it might be a counterfeit or dud. And in case you haven't studied our logistics supply issues lately, the PIC controllers are completely out of stock, and they're not due to be back in stock until sometime in July of next year, 2023. This is July of 2022. So anybody hoping to get a reliable kit, don't hold your breath. At least not something that works. If you're going to buy a kit, I would strongly urge you to contact the seller and ask them to check to make sure that the processor works. My seller on Amazon has been very forthcoming. He is actually going to send me a complete working processor board. So this is the processor, this is the processor board portion, and this is the relay coil portion. There are jumpers, as you see, that go from one board to the next. Initially, some of the kits, if you get them, the boards are going to be joined together, and you can either snap them apart or leave them connected. In this case, I received the processor board already separated from the main board. So I also suspect it may have been a used board, although there's no solder indications to suggest that. Okay, let's get to the meat of the project here. So what you're going to get is you're going to get a bare board. This board is going to be completely vacant, except for a few parts that will be soldered in, and those are LEDs and capacitors, and the reason is they're all surface mount. So anything that is surface mount is already going to be mounted. soldered to the board. The processor board, most of the parts are already installed. All of the transistors, all the drivers, the capacitors, the processor. I took mine out, I put it on a socket so I could verify that it was working. That was after I determined that it wasn't working. I bought a Picket 3 and checked it, and like I said, plugged it back in, still didn't work. The jumper there is just because in the process of unsoldering the chip, messed up the pad on the back side, so I just ran a jumper wire. You won't get connectors already installed. You'll have to install those. We'll talk about that. So all the white connectors you see and the mating cables are not installed. Relays are not installed. Chokes come just with the toroids. As you see here, these you have to wind. You have to add the adjustment potentiometers. You have to add the diodes. The surface mount resistors are already installed. And then we'll talk about the RF connectors. So there's an RF in and an RF out. These two chokes or coils, transformers, this is for the forward and the reflected power. So the RF is going to come in, go through these little wires in here, if you see them. I used 30,000 volt silicone insulated wire, not ignition cable. Ignition wires have carbon internal. This wire came with shielded internal conductor. I pulled it out and replaced it with 18 gauge bus wire. So that's 18 gauge solid wire that helps handle the power a little better. You can see the terminals from the transformers are soldered into these holes. So you're going to end up with through hole wire that goes for the center conductor, and then you have the terminations for the transformers. Now, the power going through the center conductor gets inflected on the transformer. The output goes out, goes through these diodes, which you're going to have to solder, which you'll see there's little black marks on these. Those get soldered into the board. It says you can use coax. Coax may not go into those 18 gauge holes. So that's why I'm using solid wire. The silicone wire is exactly the inside diameter of these transformers, keeps the wire centered in the transformer. Okay. The relays are a certain pattern, or keying as we call it, and if you turn the board over, you'll see there's really only one way you can install this. So you have the pattern here and here. So there's only one way for the relays to go in. If you've never wound a choke before, this is how you do it. You will see that the instructions over here talk about number of turns. So it says L1, L2, L3 is 3, 5, and 8 turns. That's these right there. Or as you can see, the ones I've made here. Okay. And it's on a 10 millimeter diameter. So you need to find something that's approximately 10 millimeters or 0.393 diameter. So it just so happens that I have a tool here where the shaft is 0.393. So I rounded around the knurled part to make those. The larger chokes, the toroids, you have to wind inside of the toroid. The toroid is the large donut that you see, and two of the coils are a single donut or toroid, and two of the coils are doubles. So what I did was I just took some tie wraps to hold them together on both sides. So it made it easier for me to wind the winding and not have to hold the toroids together. Okay. When you wind a toroid or a coil, a choke, it tells you number of turns. The turns are not, let me go over here. Okay, the turns are not based on one complete revolution. What they consider one turn is one pass through the middle, not what it takes to go all the way around the choke or the toroid. So when you pass the wire through the middle, even if you don't loop it around, they consider that one turn. So when you wind your toroid, you want to count the number of wires you see on the inside, not on the outside. Okay? So this has 1, 2, 3, 4, 5, 6, 7, 8 turns. If you counted the number of wraps on the outside, you would find there are 9. Okay, because when you come around the other side and then go down into the holes, you end up with one additional wire on the outside. So you count the number of turns on the inside, not the outside. Okay, so the first one is 8 wraps, 8 turns. The second one here, which is L4, okay, L4 and L5. L4 is 8 turns, L5 is 11 turns. L6, the first double, is 11 turns. L7 is 16 turns. So you should have 16 wires showing inside, not outside. Okay, I know it doesn't sound right, but that's the way they count it. So 16 inside here on this one. You bring the wires down, okay, and you'll solder them into here. Now, if you've never dealt with annealed wire, which is what this is not bare copper wire. This is what they call annealed or coated wire. It's got a varnish or plastic coating on it. So what you have to do is, in order to solder this in, you have to scrape the annealing, the coating, off of the ends in order to get the solder to adhere. What I strongly urge you do also is pre-tin the wires. Okay? Make it much easier to solder in. There's the connections here. Okay? So the wire is going to go into those holes and you're going to solder them. I use my X-Acto knife to scrape away the coating. You can use whatever you want. You can use sandpaper. You can use any number of things. But the copper has to be showing from the annealing. Okay? You don't want to scratch these wires anywhere around in the toroid. If they happen to touch each other, that's a short. Okay? That's why they're coated. They get wrapped around the toroid. They're coated to protect from contacting each other, even though in this case there's a rather large distance between wires. But when you're wiring something like a transformer, where the wraps have to be right next to each other, that coating prevents it from shorting out. So as I said, you have to scrape away the coating where the wire goes into the circuit board, and then take your soldering iron and pre-tin the wires. Get that solder to coat completely around that wire, and then when you stick it through the hole, it'll make it much better to solder. Okay. Relays you don't have to worry about so much. They're already pretty much pre-tinned. They just stick in the board, solder them. I suggest you put the relays in first before your chokes. It'll sit flat. Flip it over on its back. What I did was I soldered this end and this end first, and this one. This is your bypass relay. We'll talk about that in a bit. I soldered those first, and then I stuck these relays in, and I put a piece of Scotch tape over the top. Made it much easier to flip over. They don't fall out. You can solder the pins, remove the Scotch tape. So you have 1, 2, 3, 4, 5, 6, 7, 14, 15 relays to install. So again, like I said, these are also toroids. These are smaller toroids. These are doubles, as well as this is a double. So you get 5 small rings. I don't know why. There's no use for the 5th one other than maybe a spare if you happen to drop one and break it or lose it. So you have to put the 2 toroids next to each other and then wind the wire around it. A word of note, these reddish brown ones, there's one surface that is not painted. You'll notice that this side and the inside and outside are coated, whereas on the bottoms, what I call the bottoms, they are not. I sandwich my bottoms together. The reason is that the paint acts as an insulator. You really want as much of a continuous connection as possible. I even sand mine down a little bit so that the ferrite material is touching. Okay. And then on this one, I've got, you can see the painted side is facing in. I didn't turn this one around. Oh well. Anyways, it's just my preference. I put the non-painted sides toward each other. These won't matter. These are already non-painted. They're just lightly coated with some kind of a varnish. So it doesn't matter. But you have to stack these together as you wind them. So again, one pass through, even though it doesn't loop up and over, is considered a turn. So you count the number of windings based on the turns of the wires that are on the inside of the toroid. Okay, this connector and this connector. Now, if you look, there are notches in this connector. There are notches on this side on this connector. The wires form a bridge. Okay, so the notches on the connector, on the large connector, are both facing to the right. Okay. If you plug this cable in to the connectors and then put one end in, flip it over, put it into this board so that the wires don't flip over on themselves or cross, you'll find out that the notches go here and here. They go to the right. Or they can go to the left. It doesn't matter. As long as they are a pair and they're matched. This one, on the other hand, is a mirror image. So you've got notches here, and you've got notches here. Not very intuitive. But again, if you put it in the same way this one is, you're going to have to twist the wire around. You're going to short or you're going to cross. This is your forward and reflected power reading from your potentiometers, and the shaft is marked on the silk screen. So make sure that your tuning screws are where they're indicated on your silk screen of your board. So this one, again, I put the connectors in, I folded this over, soldered it in this way. Power connector is not very intuitive either. You've got, you can see plus and minus 12, plus is on this side, minus is on this side. This connector is not keyed how you can put it into the board. So again, you have a black and a red wire with a plug. I suggest you plug it into the connector and then insert it into the board and then solder it. So you make sure you have the red and the black on the right position. This cord, this cable they send you, which isn't very useful to me, unless you're going to have a very short connection to a front panel or a switch. This is your switch connector. You've got ground. You've got the RB connectors and the RA connectors. You're going to be using the RB connectors, RB1, RB2, and you'll see that on this sheet of paper. There's your button functions. So the connector that's going to, I'll show you in a minute, it's going to say button, is a tune button. RB1 to ground is auto. RB2 to ground is bypass. Okay? The tune button you press to do your tuning. Pretty simple. Auto is auto tune. So you're going to press auto and then tune, and then it'll tune. Bypass is if you don't want the tuner to be in play. All right? That's going to be this relay, right? My finger over here without, there we are. That's the bypass relay. So what happens is that the RF is going to come in here, go through your forward and reflected power coils, go through the relay, and come out here at the RF connection. So in here, out here. That's bypass. When you're not in bypass, your RF is then running through the entire network. Okay? All right. So RB to ground is your switches. Then you have a connector that's called just simply button. That's the 2-pin connector. That's the button function and ground connection. Doesn't matter which one's which, because all you're doing is shorting it to ground. The LCD output, OLED or LCD, whichever version you get. I've got these that I've had. I use these for testing. There's also a little one. It's here somewhere. I'm not sure where it is right now, but it doesn't work either. It was dead on arrival. When I plugged it in, there was not even a backlight. No display. When I plugged one of these in, I got power, I got display, and I got some blank characters to display, but no information was being sent by the processor. So there was no data and no clock. I checked with my oscilloscope. It's pins 28 and 27. That's your clock and data. No wiggles. Only one relay was coming into play. That was a bypass. Nothing else would switch. I tried shorting wires together. No connection. I reprogrammed the processor, put it back in, still no function. So, processor's DOA, OLED is DOA. The OLED, or LCD, only needs clock, data, ground, and 5 volts to operate. Okay? They give you these stupid little prototype project wires with the single wires with the black connectors. And I went out and I bought a whole set of connectors with crimp tool to make my own. So I've got my own wire sets that are going to go to my display. Master clear. You can use the master clear if you want. They don't give you a button for it. I'm going to run a button to the front panel only because people have complained that at times these things lock up. And I don't want to just cycle power. I'll just hit the master clear. That'll be a button. So the buttons they send you are cheap single pole, single throw push buttons. There's a rocker switch for the power I don't like. So I'm replacing all those. I bought a nice box on Amazon. It's 300 millimeters long. The board sets together are 270 millimeters. So 300 will give me enough space. I mount the board back here. I'll put the RF connectors in. Mount the board close to the rear. Have some gap here. Put the front panel or processor board up near the front. That'll go to my front panel, and that's where all my switches will mount. They also give you a battery connector. That's not the one, but they give you a silver battery connector. The center is hot, or at least on my power supply it is. They give you some SMA connectors, some small SMA connectors. I don't know why. They will not handle 1,000 watts. I'm just letting you know. You want the larger UHF connectors. So here's the package of parts that they give you. You can see the SMA connectors, useless. Throw them in your junk box for future projects. The UHF connectors you'll use for the RF. You can see the battery connector is right there. Rocker switch. So that's all of the extra parts that they give you. Okay. I mean, it's nice. It's nice to give you the parts. I am adding diodes to the backs of my relays. So why am I doing that? It's not in the design, but when you have 12-volt coils or larger voltage coils, you always put what's called snubber diodes. So the snubber diodes are when the electrical field collapses in the coil of the relay, it can send voltage back up the line all the way into your drivers. And if the voltage is high enough, it will destroy your drivers. So I put the diodes across those. They're 1N4003s. You can use a 4002 or 4001 because this is 12 volts, and you're going to get maybe 3 times the voltage, so about 36 volts at the most coming back in when these are de-energized. But the diode will help prevent any back EMF from getting back into your drivers. So I've got 15 diodes to put across my relays. Okay, so that's what it's supposed to look like. This is not what they send you as far as instructions. So again, this is why I'm going over it. Your connectors that you're going to solder in, your cables, the coils, the relays. Okay. I hope that helps somebody out there to assemble this thing. I will post another video later when I get my box. I'll show you where it's all connected up. I'm not going to bother with showing you how to run this thing because there's already plenty of YouTube videos on how to do that. One additional thing I did ask about the developer, N7DDC, Dave. The There's a company called LDG that also sells auto tuners. They have additional buttons for manual control, manual tuning up down of the coils and capacitors. And I asked them if we were going to possibly have a version coming out at some point that might take advantage of additional lines for manual control. So what he said is that if you press and hold all three buttons, the button, the bypass, tune, and auto, at the same time when you power up the unit, it puts it into test mode and will allow you to tune this up and down manually. So if you have any questions, go ahead and ask in the comments, and good luck. It's not that hard of a project, but it's a lot simpler when you have better instructions. So I'm hoping I provided you better instructions. Thank you.